Thanks again. This time it's not my fault, because it's it's a job from another university, it's a paper from another university. They asked me to present the work, so, no, you can ask, I'll try, but, obviously this is not my work, not of my group, so I want just to remind you that this is a work from the group of University of Bologna, and in particular the authors are Francesca Ferretti, Di Locca, Incerti, Baratucci, and Professor Savoia. And Professor Savoia was planning to come here, but at the end was unable to come, and so he asked me to gently try to summarize the results that they have achieved with an interesting experimental program on the use of CFRP rebars as a retrofitting system for masonry panels. So the topic is similar to what we have discussed before, and again the idea is to look at the efficiency of a new solution in order to increase the capacity of masonry panels against out-of-plane behavior. So we know how much vulnerable are masonry panels, and the idea is to find an innovative solution which is applicable to load-bearing elements and in field, and it allows to increase the capacity against in-plane or out-of-plane behavior in masonry, and this is probably the most important part where everyone is looking to try to find something which can be applied directly from the exterior of the building in order to be sure that we can do it even before the earthquake. And the study looks and investigates the efficiency of this solution in improving the shear behavior, sliding and diagonal cracking of single leaf masonry elements. So this is the technique. The idea, if I well understood studying the paper, is to apply an FRP rebar here along the masonry wall, and then to combine this kind of strengthening solution with FRP. So the idea is to use FRP rebars plus biaxial FRP sheets and multi-axial FRP sheets in order to be sure that the solution could increase both the in-plane and out-of-plane capacity of the masonry panel. This is the experimental campaign in terms of tests on materials. They investigated the capacity of clay brick single-leaf masonry panels. These are the properties of mortar, which is a typical M5 mortar, and brick. The red one, which is the typical of Emilia-Romagna region in Italy, in the northern part of Italy. This is the strengthening system made by carbon FRP rebars with a diameter of 60 millimeters, plus high-performance cementitious mortar, plus multi-axial carbon FRP sheet. And these are the properties of the mortar and FRP rebars and sheets. The rebars range in a typical value of around 800 megapascal, while the sheets are stronger with an ultimate tensile strength of about 4,000 megapascal. So the tests that were done were direct shear tests and diagonal compression tests. So this is the slide showing you the samples and the strengthening layout. So for direct shear tests, what they did for strengthening was this procedure. They tested two unreinforced samples, reinforced with mortar at the beginning into the grooves. So they made the grooves, which were already prepared because the lift was very blended. So they cut the blocks before. Then they filled the holes, the grooves with the mortar. And then they apply the rebar into the grooves, like you can see here. And finally, they apply the reinforcing layout with a multi-axial FRP sheet. So at the end, we have rebar plus mortar plus CFRP sheet, and this is the final configuration of the specimen. You can see here the direct shear tests, the solution that they applied with axial load and horizontal axial load applied in this way. You can see the test setup here in this picture. The test protocol, they started to apply a vertical stress of 0.2 megapascal. Then they applied the horizontal load. Then when the sliding happened, they increased the vertical load up to 0.4 or 0.6 in this range, and then they continued to apply the horizontal load. So, and here you can see the comparison in terms of force, displacement, behavior between the reinforced displacement, then the one with mortar only, and then the complete layout. And here in the table you can easily achieve the strength increase obtained by using the strengthening solution. And obviously you can see that by using the complete strengthening solution, the behavior changed a lot. They were able almost to increase by a factor of 50% the capacity. Here the comparison between the solution, which attained different failure modes, sliding, out of plane rotation, or finally the splitting, the out of plane rotation plus splatting failure of loaded plate when they used the full layout. Then diagonal compression tests, which are typically done in order to evaluate the shear capacity, considering the two parts of the force. So what they did was to test two unreinforced samples and two strengthened samples with a complete layout, which means rebar plus mortar plus CFRP sheet. You see here the panel, so there was a part unreinforced here in the middle, while at the two edges there was the bar plus carbon sheet, and you can see here the cross section with the FRP applied completely from the exterior and the two bars. Okay, this is the construction of the wall, and this is the procedure. The panel was already realized with the holes, then they injected the grout, then they inserted the rebars, and then they applied the FRP. So this is the final view of the panel after the application of the reinforcement, and these are the steps. The test setup, typical test setup, so compression tests in order to evaluate the shear capacity, exactly as we have discussed in my previous experimental program. So it's a very common type of test. And here you can see the comparison between the reinforced masonry and the strengthened one in terms of compression force versus the strain in both longitudinal and the vertical direction, and you can see the elongation and shortening, and you can see how much the strengthening solution was able to increase the capacity. So here you can see the comparison in terms of shear stress. So the reinforced specimen were able to achieve 0.39 and 0.96. Obviously, this is due to the different capacity in terms of FT, but by using the strengthening solution, the shear stress increased up to 1.38 and 1.15. showing that the solution was effective to increase both the strength capacity, but even the ductility was increased, as you can see in these pictures. Here the failure mode comparison, the very large crack in the unreinforced specimen, while in case of strengthening by using the innovative solution, the cracks were less weak, less significant, but more diffused on the panel, as you can see here. And they also tried to investigate on the type of failures at the peak by using the digital image correlation. And you can see here the comparison between the crack pattern at the peak and at the final phase on the strengthened specimen. And you can see that different cracks developed along the panel, even if obviously the biggest one is in the middle, but from the peak up to the final view, you can see the development of other cracks showing that there is an increase, a significant increase also in terms of ductility. So, in conclusions, it was tested an innovative strengthening technique based on the use of CFRP rebars plus mortar plus CFRP sheets. The investigation was both to analyze the shear behavior with direct shear and diagonal compressive tests, and the tests showed a very interesting significant strength increase, but also the change in the failure mode, because sliding failure was completely prevented, and this was a very interesting result. And so the authors are now trying, once the technique was validated on the specimens, they want to move to full-scale walls in order to evaluate the same technique and to analyze how much it can be used also on full-scale specimens and how much is the increase both in terms of strength and ductility. So this was the presentation. I'm sorry. I tried to do my best, but it's not my research. So if you have any question, I'll try to give you an answer, but obviously you can directly ask to the author for the data.
Thank you, Marco. I will ask you one question. John Myers, Missouri S&T. So in the U.S., one of the, I guess, challenges is for the, quote, pure masonry individual, you know, cosmetically, they hate when we mess with the aesthetics, the appearance of the surface of the masonry and put external type systems on it. And I'm wondering, in Italy, what's the perspective of that with all the historic masonry structures, and, you know, has there been any thoughts about, especially with some of these FRCM, cementitious bonded systems, how you might be able to put, I don't know, some type of thin coat system on to restore some of the aesthetics. So any thoughts about that?
Yeah, for sure this is an invasive solution from this point of view, let's say from an aesthetical point of view, but in some cases the seismic common solution is RC plaster, which again covers the solution. So obviously if you have an historical building, probably this could be an issue, and that's why we need to find other solutions, like the connection with the Rebars that we discussed in the previous presentation. But in other cases, there is no way to do everything, to increase the capacity without completely affecting the surface. So this is something that you cannot avoid in some cases, and especially in seismic area, you need to balance, and at the end you need to find a solution.
Yes. Here you go.
Can you apply the material to the inside of the wall and get the same result?
Inside? But removing the...
He's saying, can you strengthen the interior face rather than just the exterior?
From the interior, when you apply on one side, this could be a solution, but typically people doesn't like that you come inside, no? That's why we are looking at outside. And then there is the, in a lot of cases, you need to consider that there is the plaster, no? Covering the masonry. So the problem is when the masonry is completely uncovered. But there are a lot of masonry buildings which are covered with plaster, and in this case, there is no problem, no? Sure, when there is an aesthetic problem, you can act from the interior side, but in this case, obviously, you need to ask the people to go out from the building. No? I guess 0.90. Yeah, I guess.
It should be in the front.
Thank you.